Hello, this is Mr. Huber. In this lesson, we're going to learn some more about slope-intercept form. We're going to talk about how to write an equation of a line in slope-intercept form. So let's remind ourselves, what is slope-intercept form? It is the form y equals mx plus b. It's called slope-intercept because we have the slope m and the y-intercept b. Okay, the slope-intercept form. So for instance, if we know the slope of a line is 4 and the y-intercept is 6, the equation of the line would be y equals 4x plus 6. Back that up. If we know the slope of the line is 1/3 and the y-intercept is -2, we'd have y equals 1/3 x minus 2. Slope goes in for the m, mx, so 1/3 x, and the y-intercept is -2, so that'd be like a plus -2. We can just write it as -2. So we plug the slope in for m, the y-intercept in for b. You've got your equation of the line. So the two things we need to know every time are the slope and the y-intercept. So let's see how we can use that, find those things out, and write our equation of the line. If we look at this line that's graphed, we want to write its equation, we need to know the slope and the y-intercept. So let's talk about the slope, the rise over run. You can set up and do y2 minus y1 over x2 minus x1, or you could just count rise 1, 2, 3, 4 positive and run 1, 2, 3 positive. So the slope is a positive 4 over a positive 3. And the y-intercept is that point right there. It's the y value when x is 0, -5. So the equation of this line would be y equals 4/3 x minus 5. We've got our slope and our y-intercept, the two things we need to be able to write the equation of that line. Now let's say there's no graph, and we've got these 2 points, -3, 1 and 0, -8. We could find the slope by calculating y2 minus y1 over x2 minus x1. So that's -9 over positive 3. -8 minus 1 is -9, and 0 minus -3, that's like 0 plus 3, so it's positive 3. That would come out to -3. And the y-intercept is right there. It's the y value when x is 0. So the y-intercept is -8. So the equation for our line would be y equals -3x minus 8. You need the slope, in this case -3, and the y-intercept, in this case -8. We're not always going to have a y-intercept that's given to us where we have one of the points with an x value of 0. For instance, if we want to write the equation of the line through the points -5, 8 and -6, 6. We can calculate the slope. That'd be 6 minus 8, y2 minus y1 over x2 minus x1. So it's -2 over -1. 6 minus 8 is -2, and -6, right, minus a -5 is like +5, so it's -1. That comes out to a positive 2. So now what's our y-intercept? We could say maybe we can graph it, but you'd have to draw a really exact graph to find the exact point where it crosses the y-axis. So if we want to get exact, let's use some algebra methods here. We can take the form y equals mx plus b. And we can take either of these 2 points up here, -5, 8 or -6, 6. Let's just take the first one, okay? We're going to plug that in, and we're going to plug the 2 in. Where are we going to plug them in? We're going to plug them in for, this is x, y, and this is our m. So we're going to plug them in for those spots. The y value would be 8. The m, the slope is 2, times x is -5 plus b. Because we don't know what b is, that's what we're trying to find out. So we plugged -5 in for x, right? For x. We plug the 2 in for m, and we plug the 8 in for the y. And now we can solve this. We'll have 8 equals -10 plus b. And when you add 10 to both sides, you get 18 equals b. So now we have the two things we need. We have the slope and we have the y-intercept. If it says to write the equation, we can't stop yet till we actually write the equation. Y equals 2x plus 18. That would be your answer. That's the equation of the line that goes through those 2 points. You could check this as well by plugging in a point. I would say it might be good to plug in negative 6 comma 6. We want to make sure all the points work. Okay, so if I plug negative 6 and 6 in for the x and the y here, I'll get 6 for y equals 2 times negative 6 plus 18. It's a little sloppy there. Let's make that 18 a little clearer. So that's 6 equals negative 12 plus 18. That's 6 equals 6. That seemed to work. Keep in mind, we could have plugged in the negative 6 comma 6. Okay, let's change all that here. Okay, if we want to plug in negative 6 comma 6 and see how that works, we can do that. Okay, we do it just like we did over here on the other side. We're going to take our y equals mx plus b form, and we're going to plug in for y a 6. Right, this is using the point now, negative 6 comma 6. And our slope is still 2, and our x value is negative 6, and then plus b. So we have 6 equals negative 12 plus b. And when you add 12 to both sides, you're going to get 18 equals b. Right? Still the same y-intercept. It doesn't matter. So you can use any point you want in the slope to find that y-intercept. Right? Then again, our equation of our line will be y equals 2x plus 18. Okay. You could go back up and say, well, could we do that up here? Well, let's find out. Okay. Let's take the point negative 3 comma 1. Okay. So I'm going to take a y equals mx plus b, and I'm going to use the point negative 3 comma 1. Okay. And our slope here is still negative 3. So our y value is 1 equals slope negative 3 times x value negative 3 plus b. That's 1 equals 9 plus b. When you subtract 9 on both sides, you get negative 8 equals b, and you'd still write that same equation. So if you don't recognize that they're actually giving you the y-intercept of 0 comma negative 8, you can find the y-intercept by plugging the point in and solving for b, and you'll still get that same answer. Remember that if you're asked to write the equation, don't stop until you have a y equals mx plus b equation written. All right, let's take some break for triple-double trivia. Who's the only NBA player to average a triple-double for an entire season? Okay, right now it's pretty amazing when a guy gets a triple-double in one game. That's a big accomplishment. Can you imagine doing that game after game after game, averaging, okay, a triple-double for an entire 82-game season? That's a pretty remarkable feat. It's only one time by the big O, Oscar Robertson. He did it in the 1961-62 season. It was just his second year in the NBA. Actually, his first year, he came 0.3 assists away from averaging a triple-double, 0.3 assists per game. He was almost a triple-double his rookie year. His second year in the league, he averaged 30.8 points, 12.5 rebounds, and 11.4 assists per game. Pretty remarkable. He came out of the University of Cincinnati, where he won college basketball's player of the year twice. He led the country in scoring all 3 of his seasons he played for the University of Cincinnati. And then he was drafted by the Cincinnati Royals. Yeah, the Cincinnati Royals were an NBA team back in the 60s. He got drafted by in 1960, and again in his second season there, averaged a triple-double. He was later traded to the Milwaukee Bucks, where he won an NBA title in the 1970-71 season, his first year with the Bucks. And he finished his NBA career, 14 years, with average of 25.7 points, 7.5 rebounds, and 9.5 assists per game. Pretty remarkable averages for a career, and again, the only time anyone's averaged a triple-double for an entire season. He was named NBA MVP once and an All-Star 12 times in his 14-year NBA career. And actually, the College Basketball Player of the Year award was named after him in 1998, which is pretty fitting since he won the first 2 that were ever given out himself. Oscar Robertson, there you are. All right, let's have you practice writing the equation for a line. You've got a couple of points there, 15 comma 2 and 5 comma negative 4. Write the equation of the line that goes to those 2 points. Press pause, try it on your own, and then let's see how you did. Okay, now you've had a chance to look at this problem and try it yourself. Right, we need the slope and the y-intercept. So the slope here is going to be -4 minus 2, not minus 6. I'm getting ahead of myself. I'm thinking what the answer would already be. Right? And then I've got 5 minus 15. That's going to be -6 over -10, which reduces to 3 over 5. Positive, -6 over -10 is a positive 3 over 5. And now if I want to find my b value, right, I take my y equals mx plus b form, and I plug in either point. I'm going to take the point 15, comma 2. If I can avoid taking negative numbers, I'm generally going to try to do that. Okay, so I'm going to have 2 equals 3 over 5 times 15 plus b. So if we make that 15 over 1, that reduces to 1 and 3. That's going to be 9 plus b. And when I subtract 9 on both sides, I'm going to get -7 equals b. So now my equation for my line is going to be y equals 3/5 x minus 7. And that should work if you took the point 5, comma -4 and used that instead of point 15, comma 2. And if you want to check it, if you're writing the equation of a line, every point on the line should be a solution for the equation. So you could even take that point, plug it in there, and make sure it works. Let's do that. I'd have -4 equals 3 over 5 times 5 minus 7. It's -4 equals, those will cancel, 3 minus 7. I'll get -4 equals -4. That checks. So the point 5, comma -4 works. I could be pretty confident that's my right equation for the line. Y equals 3/5 x minus 7. Let's talk a little bit about real-world applications here. Remember, when we talk about slope, that's a rate of change. When we're dealing with a real-world scenario, we use the words rate of change instead of slope. And that b value, right, the y-intercept, if you will, is the starting value when x equals 0. So if we look at this situation here, this is we're shopping for presents for family members. All right, that's nice of us. We want to buy them sweatshirts that cost $35 each, and we have a gift card we're going to use for $20. Okay, help us with the cost. If we write an equation for this, right, our rate of change, our m is 35, and our b value is going to be 20, right? If we don't buy any sweatshirts, right, we're going to take $20 off. So it's not going to be a positive 20. We're not going to have to pay $20. We're going to be taking $20 away from our cost. Our total cost is going to be $35 for every sweatshirt. If we buy 2 sweatshirts, it'd be 35 times 2. If we buy 10 sweatshirts, it'd be 35 times 10. But we also are going to take away $20 from our total cost because of the gift card. Right? The gift card's taking 20 away from the total cost. So it'd be our equation that would model that situation. If we looked at this a little further, let's say we drew a graph. Let's count by 20s. 20, 40, 60, 80, 100. It'd be -20. Right? Our y-intercept here would be at -20. And let's count by 1 sweatshirt each. 1, 2, 3, 4, 5. Right, this is 20s. That's our x values and our y values. If it didn't tell us in the problem to use x and y, we used whatever variables we wanted to make sure we define them. Okay, so if we buy 1 sweatshirt, it's going to be $35 minus 20. That's going to be 15. So 1 sweatshirt is going to cost us $15. That'd be like going from -20, going up 35 and over 1. We could go up 35 and over 1 more. If we go from 15 and add 35, where we'll be at? We'll be at 50. And we go over 1 more. So we go up to 50 and over 1. Again, if you plug a 2 in there for x, you get 35 times 2 is 70, minus 20 is 50. So we have an equation that we could graph that would look like this. In all reality, this part of the graph is going to be meaningless because we're not going to buy 0 sweatshirts and get paid $20 necessarily, or have a -$20. We'd really want to start right here with this part of the graph where we would have bought 1 sweatshirt or 2 or 3 or 4. You're not going to say what would happen if I bought 0 sweatshirts. Okay? So that would be what our equation would look like. And again, each sweatshirt we have would add $35 onto the cost, starting with $15. Because if we buy one sweatshirt, it's going to cost us $15 after we take the 20 away. All right, now that you've seen a few examples of writing equations in slope-intercept form, remember we need the slope, the m, and the y-intercept, the b, and then we can write our y equals mx plus b form. We found different ways where we can calculate the slope with a graph or using a couple points, and also where we can read the y-intercept from a graph or points or calculate it ourselves. Solve for that b. When you're asked to write an equation, you need an m value and a b value to put into your y equals mx plus b equation. And have you practiced a few more in the quiz that's posted on Moodle for 5.3 day 2. Good luck.